Hi class. Okay, today we're covering section 6.1 on scatter plots. Make sure you've read the text before you start this video, so read this section in your textbook. But we are going to cover scatter plots today. So one thing this section starts out with is a review of explanatory and response variables, which we talked about back in chapter 4, yes, I believe, with all the statistical stuff. Chapter 3, I think, even back as far as that with statistics. So remember here that we use X to represent, oops, my pen here is going a little crazy. All right, let's try that again. We use X to represent our explanatory variable, and we use Y to represent our response variable. Okay, so remember here, explanatory is your input variable. It's what kind of you're looking for the response variable to respond to the explanatory variable, or the explanatory variable to explain the response variable. So we're going to be doing some practice today on determining what the explanatory and response variables are, because we want to be able to put this information into a condensed form called an ordered pair. Now, we've seen ordered pairs when we looked at, back in chapter 1, plotting ordered pairs in a coordinate system. So you want to remember here that ordered pairs always come in the form X and then Y. We always have those parentheses and a comma to separate them. But what we're going to be doing today is looking at ordered pairs and then converting them back to their explanatory and response variables and what they mean. We're going to look at some exercises from your textbook to practice this in these notes today. The first exercises we're going to look at are 17 and 18 on page 374 of your text. So these are the exercises here. I'm going to zoom out so we can see them. There we go. And we're going to go through these and understand, first of all, how to figure out what the explanatory and response variables are, again, to know how to put these into an ordered pair. Okay, so putting information into ordered pairs. And this exercise, let's start with exercise 17. We have T, which is the number of t-shirts sold in thousands at a hip hop concert that at a hip hop group sells, okay? They're selling them at C concerts per year. So we have two variables. Now, what we don't know right now is if the ordered pair should look like T, comma, C or C, comma, T. In order to determine that, we have to know which one is going to be our explanatory variable and which one is going to be our response variable. So again, kind of a good thing to do is say, okay, does the number of t-shirts sold affect how many concerts per year I'm going to have? Would I be looking at that? Or would I be looking at, is the number of concerts I hold per year somehow affecting the number of t-shirts I sell? And we'd have to have a concert in order to sell t-shirts at those concerts. So we're going to see that C here is our explanatory variable and T is the response variable. Okay, we would not be able to look at then t-shirts somehow affecting the number of concerts that we have. All right, so once we determine the explanatory and response, we can put the explanatory in the first position and the response in the second position. So then we're just going to create the ordered pair that this information has next. So it says a group sells 294 29.4, I don't know where I got 29.4 thousand t-shirts at 98 concerts in a year. Be careful with the units here. So when I put this into the ordered pair, I'm looking for C first. Concerts per year was 98. And then there's a little bit of a question with the t-shirts as to whether or not I need to put 29.4 or whatever 29.4 thousand would be. And since my unit for T is in thousands up here, we will just put 29.4 because the unit means that that is 29.4 thousand, and we have that part already assumed from the way we've defined our variable. Okay, let's try number 18 for more practice here. Again, creating an ordered pair from information. This one says P is the asking price and B is the number of bedrooms in a home. Again, pay attention to units here. The asking price is going to be in thousands of dollars. So, does our asking price somehow affect the number of bedrooms our house has, or does the number of bedrooms our house has somehow affect the asking price? And when we ask a certain amount for our house, it will be determined partially by the number of bedrooms. So bedrooms is affecting the asking price. Okay? So again, we want to create that ordered pair here. So the ordered pair for the information is that we have a 3-bedroom home and we're asking $152,000. So what would that ordered pair look like? You should get 3 since it's 3 bedrooms, and then 152, which means the asking price is 152,000. Okay, so there you go. You've got it. There's the ordered pairs that represent those scenarios. All right, so we can create ordered pairs to summarize information. Or sometimes we can be given those ordered pairs and need to understand what they are representing. So let's do that in reverse with exercises 23 and 24 on page 374 of your textbook. Let me zoom in a little bit here so you can see those a little better. All right, let's start with 23. Here again, we have 2 variables. P is the number of ounces of a new protein shake a weightlifter drinks daily for 6 months. Okay, that's a lot of information, but summarize it up in your head, the number of ounces we drink in our protein shake. Okay? N then is the number of times the weightlifter can bench press 200 pounds after those 6 months. So we're going to drink some protein for 6 months, and then we're going to bench press after those 6 months. So that one's a little bit easier to really determine what the explanatory and response variable is, because we're going to do the first thing, and then we're going to do the second thing, right? We're going to drink the protein for 6 months, and then we're going to see how much we can lift after those 6 months. So in this case, it would have to be that P comes first, and we're going to see if it at all explains N. All right, so then if that's what we have the ordered pair already. It gives us next that we have 16/8, and we want to explain that in this situation. So don't leave out any part of this information, okay? So let me see if I can't type this information out instead of writing it. All right, so 16 is P. So 16 is the number of ounces of a new protein shake a weightlifter drinks for 6 months. So what we're saying is that after drinking, 16, and the unit is ounces, of the protein shake for 6 months, then we see that the weightlifter, don't need to capitalize that, can lift 8 and then go back up to the unit there. I don't want faces. There we go. Can lift 200 pounds 8 times, right? It's how many times they can bench press 200 pounds after those 6 months. So they can lift 200 pounds 8 times. It's not that they're lifting 8 pounds, right? Always go back to the information to figure out what's going on there. Keeps wanting to capitalize that T on me. Oh well. Okay, so after drinking 16 ounces of the protein shake for 6 months, That's all summarized in just the P variable. The 8 then means that we can lift 200 pounds 8 times, okay? So you want all that information. Don't leave any of it out. It might seem like you're repeating a lot, and you are, but you want to make sure you really do describe what that ordered pair means in this situation, right? You were asked what this ordered pair means in the situation. That is what the ordered pair means in this situation. Okay, let's try 24. So make sure you get all that information in there. So maybe pause, try 24, and see if you get the correct answer. In this one, S is the mean number of times a television salesperson compliments customers per day. So again, in your head, but while you're determining explanatory versus response, shorten that up. So compliments. S is basically the number of compliments per day. And then C is the mean number of televisions the salesperson sells per month. So shorten that up. C is the number of televisions sold. So does complimenting a customer affect the number of televisions I'll sell? Or does the number of televisions I sell affect how many times I compliment the customer? Well, even think about that. I probably won't see the customer again after I sell the television. So I'm going to compliment them in order to get the sale, right? So here you should have that S is explanatory and C is the response. So our ordered pair we have is 72, 39, and we want to put all those units back in when we describe what that ordered pair means in this situation. Okay, so 72 is the mean number of times a television salesperson compliments customers per day. So 72 compliments per day, that's our unit, results in, and we might even hear 72, compliments per day results in a mean of, let's see, what was it, 39 sales per month, okay? Results in 39 televisions sold per month. And to put that mean part in there, I would say at the very end, on average, because we know that these are means that we're looking at. So it's not exact numbers, it's saying the mean. So 72 compliments per day on average results in 39 televisions sold per month on average. Right? So that per day was very important. Not 39 televisions sold, period, 39 televisions sold per month. Don't forget any of those units. Okay, so there we then again described what does this mean in the situation right there. Okay, now most of the time we have more ordered pairs, right? Even looking at this data, we would say, okay, if we change the number of compliments, then how does that affect the mean television sold? And we want to look at this relationship, and the best way to do that is to summarize all the data points we have in a table or in a coordinate plane, okay? So we're going to look at here, how do we summarize this information in tables and those coordinate planes or coordinate systems we looked at back in chapter 1. So there's a standard here. For tables, the explanatory variable will always go on the left, and the response variable will always go on the right. And then we can list out a bunch of ordered pairs in this table. We'll see an example of that here in a second. If we're using a coordinate system, we just want to remember coordinate systems are the two axes together, and that our explanatory variable in coordinate systems goes on the horizontal axis, and the response variable goes on the vertical axis. And these are great ways to summarize the information in a table and then visualize the information in a coordinate system. So we want to look at an example of doing that. We're going to look at example 4 on page 368 of your textbook, and I have that data right here. That example looks at over time, so as we look at more and more Super Bowls over time, how did the mean ticket price change in order to go to the Super Bowl? So you'll see it's changed quite a bit. So we started with Super Bowl I, it only cost $12 on average to go to the Super Bowl for the first Super Bowl. You can see that price goes up over time, but not very fast. 4 years later, for Super Bowl V, we've got $15 is the mean ticket price, but you can see it goes up very quickly. At Super Bowl 45, it was $900. In fact, I looked up Super Bowl 50 as well, which is hard to create a scatter plot with it because it jumped all the way to about $4,800 was the mean ticket price in Super Bowl 50. I think this last Super Bowl, it was right around that too, like right around $5,000. So crazy how fast it's gone up. So we can see how fast it's gone up with the numbers. We can visualize that increase even better in a scatter plot. Okay, so that's what we're going to create with that coordinate system, is something called a scatter plot. So you've read about those in section 6.1, but what a scatter plot is just a coordinate system with all of those ordered pairs. So a coordinate system, so those axes with plotted ordered pairs. So what we're going to do is plot all these ordered pairs we have into one coordinate system to create a scatter plot. We looked at very similar things when we looked at time series plots, but the big difference here, and one that I see students kind of forget about and mess up sometimes, is that in a scatter plot, we do not connect the points with a line. We only want to see those coordinate points. We are not going to connect them with a line, okay? It's going to be very important as you look at the scatter plots in this section. Okay, so let's create a scatter plot with this data. So as we saw before, because of the way this table is set up, we know that our explanatory variable is the Super Bowl number, and the response variable is how the mean ticket price has responded over time. So in my coordinate system that I'm going to create, I'm going to set up some axes down here, and then we'll pull the data back up. Okay. I'm going to have a coordinate system where I need 2 axes. These are all positive numbers, so I just need the positive axes. Okay. Where my explanatory variable is the horizontal axis. So down here I have the Super Bowl number. And my response variable is the mean ticket price in dollars, okay? So that's how my variables get set up, since I know what my explanatory and response variables are. Now I need to set up my axes so that they span the numbers. You can see up here the Super Bowl number goes from 1 to 45. So I'm going to go by 5s on my axis here. So I've got 5, 10, 15, 20, 25, 30, 35, 40, 45, okay? And then our ticket price spans from 12 to 900. So I'm going to go by hundreds here to get that to fit in. 100, let's see if I can get the space to be a little more accurate. 200, 300, 400, 500, 600, 700, need a little bit more space here, 800, and I ran out of space, 900. Okay, so get those spaces as well as you can. All right, and now we're going to plot each one of those coordinate points. So I'm going to go back to the top of my data set. The first point I'm going to plot is 1, 12, and that is in the correct order. It's X and then Y, so I need to go to 1 on my X axis and 12 on my Y axis, and I'm going to approximate the best I can. So 12, since just one step is 100, is going to be really close to the bottom. So 112, and that point is down here. I'm going to plot it the best I can there. Okay? Then I've got, goes up just a little bit to 515. So I move over to 5 on my x-axis and up to 15 on my y-axis. So 5 and just above that point. We can almost not tell the difference since the scale is so big. Okay? Then 10, 20. So again, just goes up just a tiny bit at 10. 15, 40. So we should be almost halfway up that 100. So I think I went a little too high there. Just a little bit more up. Okay? So we've done 10 and we've done 15. Now we need to go to 20, 75 and then 25, 150. So 20, 75 would be just about 3/4 of the way up towards 100. And 25, then these are going to start to get easier to plot. 25, 150. So that's about halfway between 100 and 200. 30, 250. So up here. 35, 325. And again, I'm just approximating these the best I can. 46, 50. So that starts to get really high. And then 45 is up here at 900. And do not connect those, okay? So do not say, oh, it looks about like that. Nope. Only leave the dots, okay? That is our scatter plot. As messy as it may look on my screen, okay? Scatter plots are, of course, done better by technology, but we get the idea. And now what we can see is the overall shape of that graph, okay? And that's what we're going to talk about in the next part, right? I'm already thinking about the shape there. I'm already thinking about the fact that this graph is increasing and visualizing this change. We're going to describe all of those changes in section 6.2. But that's how we want to construct those scatter plots. It's just, excuse me, a matter of plotting a bunch of ordered pairs. All right, guys, email me when you have questions. Try that 6.1 homework.